Okay, looking at section 2 of chapter 9, we're going to be looking at our reciprocal function family. So we're going to be looking at a parent function and then how it's manipulated to change, either growing, shrinking, shifting left, right, up, down. Okay, so we're going to be looking at specifically the reciprocal function, which is like 1 over x. Okay, so we're going to be looking at 1 over x and how it can be manipulated. So first off, this is what the reciprocal function looks like. Okay, so it's basically the parent function, so the base of it, where all the other ones are born out of, is y equals 1 over x. And as you notice here, it's this red line. You've got it falling, and you've got it falling as it approaches 0 from the negative side, and you've got it growing as it approaches 0 from the positive side. And you see they won't touch each other. Okay, there's a break in it. And they kind of stay in their own quadrants. So if you don't have any type of shifting or anything, one of the, what they're called branches, one of the branches is going to stay in the first quadrant and one of the branches stays in the second or the third quadrant. Okay, so they stay in there and they don't cross over. You see they don't cross the x-axis anywhere and they don't cross the y-axis anywhere. Okay, they don't touch to cross it. Okay, these are called asymptotes that they run into, which we'll discuss more in this whole section and chapter. Okay, so this is the reciprocal function. The next one, which is just the mirror image flipped, is if you have y equals -1. So if it's a -1 over x, so if that fraction's negative, what ends up happening is that you start in the second quadrant and you end in the fourth quadrant. Okay, so if it's positive, it's 1 and 3. If it's negative, it's 2 and 4. Okay, and that's your branches. Okay. Which, again, you can check this by either A, type it into your calculator, or B, making a table and graphing the table. If you plug in a +1, what do you get? +2, yada, yada, yada. Okay, so here is the general formula for the reciprocal family. So this is what you would see, and you can manipulate everything by just changing those three variables, a, h, and k. Now we've seen h and k many, many times dealing with the vertex of a parabola, anything like that. So those aren't too new. And a is going to change the steepness of it, which we've also talked about with a parabola, where if the a is larger than 1, it becomes real narrow. If it's less than 1 but more than 0, it becomes wider. Same thing happens here. So a changes the steepness of this. So the red one on this graph, so the middle function is your y equals 1 over x example. Okay, the blue one ends up being y equals 4 over x. So as you see, if the a value is increased, that branch is being pulled away from the origin. Okay, and then the last one, the green one, is y equals 0.5 over 1. And as you see, if it's less than 1, it ends up getting pulled closer to it. So if the a value is more than 1, you're pulling it away from the origin or that center where the asymptotes cross. If it's less than 1 but more than 0, obviously, you pull it closer. Okay, you can kind of think it's a steeper drop if it's less than 1. It's a more gradual curve if it's more than 1. And that's if all we're looking at here is the a value. Okay, so the next thing is our vertical and horizontal asymptotes. So the vertical asymptotes, which is up and down, vertical is up and down, is affected by the h. Okay, so the h is what affects the vertical asymptote. So again, the red function is our general base function for these. Okay, it's our y equals 1 over x. But in this function, you see that you have a new asymptote. It's been shifted over 5. So that means that the blue function is going to have an equation of 1 over x minus 5. Okay, so it's moved over to the right 5. So what you've heard before, since x is negative, it moves to the right. When x, or if it's x plus a number, you move it to the left because lefties are better, plus. Okay, and so that's how your vertical shift happens. Okay. Now if you look at the second one with our horizontal shift, that is the number on the outside of it. So you see here, this has been shifted up 5, which means our equation would be y equals 1 over x, and then outside of it we add 5. Okay, so a horizontal shift is added outside of the fraction. A vertical shift is added in the denominator of the fraction. Okay, so shifting left, right, up, down. Okay, so let's say we want to write an equation that has this translation. That's what's happening here, is that we're doing translations of a parent function. So y equals 4 over x is our basic function, and what we want to do is we want to translate it. We want to move it around. So take a second, figure out what the equation would be if we have an asymptote at x equals -3 and a y at 8. Okay, so hopefully you ended up with an equation of y equals 4 over x plus 3 and plus 8. So again, the y is going to, this ends up being your k, and this is your h. And remember that since you moved it -3, which is moving it to the left, you have to switch that sign. So the one underneath is always going to have the opposite of the sign of what was given. The y is always going to be the same sign. Okay, so now take a second to write the equation for this function. Okay, so with this one, we'd end up still with y equals 8 over, but it'd be x minus 9, and then be minus 4. Okay, because you are subtracting 9, you're shifting it to the right. Okay, 9 places, and you're shifting it down 4. Okay, so now if we want to graph these, first thing we want to do is identify what our asymptotes are. So, what is our vertical asymptote? Right, our vertical asymptote is going to be at 2, and what's our horizontal asymptote? That's going to be at 4. So, our vertical and horizontal asymptotes are at 2 and 4. So what we want to do is we basically want to draw a line, or a dotted line, going along those asymptotes. Okay, and that's going to kind of be our base we have. Now, once we have our asymptotes drawn, now we have our branches that we have to draw. Now, with these, for the most part, you don't need it to be perfect. For graphing it, you can always just pick points. So if I plug this in, what do I get? When I plug this in, what do I get? But since this is positive, that means we're going to be in the first and the third quadrant of that. So that means we're probably going to be looking at something like this and something like this. Okay, which my graph will come up. So as you see, we drew our asymptotes, which my lines aren't straight, but you see where the curve is. You can see what the curve would look like. Okay, so when you're graphing these, you want to graph the asymptotes and then do the curves from there. Okay. All right, so that's it for this section. Basically, it's just the translations moving up, down, and then the rough sketches. This is section 2 of this chapter. We're going to be doing more with rational functions as we continue.